Hi everyone, this is Jack, and today's topic is bonding. Bonding may sound like a form of companionship between friends or parents, which wouldn't be wrong, but understanding the terms of bonding in chemistry is a little different. Chemical bonding is an attractive force that binds atoms or ions together as a unit in order to increase stability. Only bonding is a general term. It can be broken down into three primary types of bonds, which are ionic, covalent, and metallic bonding. Simply put, ionic bonds are the bonds between two atoms with greatly differing electronegativities or oppositely charged ions. Sodium chloride, known as table salt, is a great example of this. Another type of bond is covalent. This is when atoms share electrons to form a full outer shell. An example of this would be oxidine, or H2O, or plainly just water. And the last bond is metallic bond, which is a force that holds atoms together in a metallic element together. Understanding these bonds can help us learn more about their valence electrons and how they interact with the types of bonds. Ionic bonds are formed through the exchange of valence electrons between atoms, so typically a metal and a non-metal. The loss or gain of a valence electron allows ions to obey the octet rule and become more stable. And the octet rule is about how atoms tend to form compounds in ways that give them 8 valence electrons, or a full shell, meaning stability. For covalent bonds, the electrons are shared. The example of water, H2O, hydrogen has 1 valence electrons while oxygen has 6. So 2 hydrogens and 1 oxygen bond to create a compound with 8 shared electrons, creating a stable compound. The valence electrons of metallic bonds are loosely connected with their parent atom because metals have an excess of electrons in their outer orbitals, even above the stable configuration. So a sea of electrons is formed, which surrounds the positively charged atom of the interacting metal ions. So I hope that makes a little more sense of how and why bonds do what they do and why they need to form. But the last thing I want to talk about is periodic trends and how they affect bonding. So I'll be explaining the three main periodic properties that contribute to the outcome of bonds to help give a deeper understanding of the concept. The first is atomic radius. So this is where it's the size of the atom. The trend in the atomic radius increases left and down in a periodic table. Now, in a larger atom with more electrons, the valence electrons are going to be further from the nucleus than in a small atom. So it becomes easier for a valence electron to leave the atom and form an ionic bond or to interact with another atom to form a covalent bond. For ionization energy, which is the amount of energy required to remove one electron, the trend increases upward and to the right in a periodic table. When looking at the elements with low ionization energy, there is more of a promising chance to form a cation, which is a positively charged ion, and in turn it will have a greater disposition to form an ionic bond. And lastly, electronegativity. Electronegativity measures the tendency of an atom to attract a shared pair of electrons. The trend for this increases up and to the right on a periodic table. So differences in electronegativity affect the extent of sharing covalent bonds. So for example, fluorine is the most electronegative atom because it is 1 electron away from a full outer shell, and it has a small atomic radius, which makes it want to bond to become complete. On the other hand, the noble gases do not have electronegativities because their shell is complete. And that's it. Thanks for tuning in and learning about the types of bonds. Because after all, sharing is caring. Just look at covalent bonds. Anyways, stay positive.